You're not done when it works, you're done when it's right. I love this quote from Robert Martin and think it speaks so much to what software engineering is all about. Writing code that works is fairly straightforward, but it's a whole other challenge to write code that augments a project and is a pleasure for other engineers to work on. Not surprisingly, this is quite difficult. Code, especially at scale, seems to follow these odd rules of entropy. No matter how meticulous an engineer, the code will grow more and more complicated over time, seemingly on its own. Complicated code leads to frustrated engineers. Frustrated engineers lead to bugs. Bugs lead to more frantic, complicated code, and before you know it, you're looking at a big pile of spaghetti. Complexity is the silent killer of all source code, so it's not surprising that managing complexity in software design is widely regarded as the most important job of any software engineer. Managing complexity is the most important technical topic in software development. In my view, it's so important that software's primary technical imperative has to be managing complexity. This quote comes from Code Complete by Steve McConnell, and if you dig through just about any software engineering book, you'll find similar trends. Your job as a software engineer, above all else, is to fight complexity. So how is this the case? Ask anyone that deals with code and they'll, of course, agree they never want complex code. So how do developers with very pure intentions let complexity sneak right under their noses and into their projects? And more importantly, what can we do to stop it? Let's take a look at a very real example that I've encountered. I'm used to developing in Ruby, and the convention for variable and key names is all lowercase with an underscore in place of a space. This is very common and you'll likely recognize it. One day, when building a service that interacted with a fussy API, we discovered that the API was expecting the payload keys to be in Pascal case, like this. Ruby is perfectly happy with Pascal case. It's only a convention to use all lowercase letters with an underscore after all, so let's just change the keys to Pascal case and be done with it. Such a simple solution and one that would work, so a no-brainer, right? Not quite. This approach would have added just a little complexity into the codebase, and while not devastating, let's take a look at why this wouldn't have been the best idea. For a moment, let's imagine we do go with the Pascal case solution. We deploy the code and everything is fine. Some time passes, and several months later, a new developer has to add a feature to that same service. They open the file and see this odd, non-conventional Pascal-cased payload. A very reasonable thing to ask at this point would be, why are the keys like this, and was this a mistake? Dramatized for effect, however, the fact still stands that we've committed code that is going to needlessly trip another engineer up. This is a big sign we failed to manage the complexity of our code. We, as the author of the code, have the siloed knowledge of why this choice was made, but to the future reader, that could also very well be us, this is now an annoying puzzle that has no obvious solution. We've perfectly set the stage for a bad decision to be made and for bugs to be introduced into our code. All of this from a simple, logical change. So what would an acceptable solution be in this scenario? Complexity is the target of just about all engineering tricks, so there is no one correct solution. As long as we're balancing the developer's quality of life against what the system and the business require, then we should be on track to having clean code and happy customers. However, here's a solution that I think would be acceptable. Let's create a method that will take care of converting our keys into Pascal case. We'll call it formatOutboundPayload. We'll then call this method right before we send the payload. This, despite being a really simple change, directly tells the next reader, yes, we are doing something odd with the key values, but it's for a reason. This tiny piece of context should now be enough to communicate that a logical choice was made and not present itself as a mystery. Again, this is just one solution and I'd encourage you to think up your own. There is actually a general formula for calculating complexity on a system level. This may look a little intimidating, but it's simply the system complexity, C, is equal to the sum of the complexity of each part of the system, C sub I, multiplied by the average time it takes a change to be successfully made to that part, T sub I. So in plain English, system complexity equals the sum of each part's complexity multiplied by the average time it takes to update each part. As a strict mathematical formula, this is actually pretty useless, as complexity is completely subjective. Even so, I do like how it gives us a soft metric to follow on a macro level. It's very easy to ask yourself, am I adding complexity to this part or the time it might take someone to edit this part? If so, you're likely throwing off this part of the equation, adding to the system complexity, which is a good time to rethink your strategy. Complexity in your code is inevitable, but managing it is up to all of us. Take some time to think about the complexity you might be adding and what you can do to tackle it. Thank you very much for watching. Please subscribe for more videos related to software engineering and computer science.